Okay, to fill in this table for the types of collisions, let's start with explosion. In an explosion, we're gaining potential energy. And where's that potential energy coming from? It would have to be from some of the potential energy, whether it is electric potential energy, gravitational potential energy, or chemical potential energy. Potential. So that's what's happening during an explosion. We're gaining kinetic energy from potential energy. So chemical potential energy, fireworks, into kinetic energy. Little pieces flying out and getting all over my yard. Relationship between initial and final kinetic energy. Well, if we're gaining kinetic energy, then that means our final kinetic energy is going to be greater than our initial kinetic energy. Relationship between initial and final momentum. Momentum is conserved in this instance. Our initial total momentum equals our initial total momentum in the end. Add up all of your momentums. If you have two objects, you add up 2 momentums. If you have 10 objects, you add up 10 momentums. For an elastic collision, we're going to keep all kinetic energy. So kinetic energy is the same. This is really for perfectly elastic. Kinetic energy is the same. Relationship between initial and final kinetic energy. Kf is going to be equal to Ki. And then the relationship between the initial and final momentum, it's conserved. So, same thing. All of our momentums in the beginning have to equal all of our momentums in the end. For an inelastic, we lose some kinetic energy to other forms. So we lose kinetic energy to some dissipated energies. Heat, sound, that kind of thing. So our final kinetic energy is less than our initial kinetic energy. Is all of our momentum conserved, though? You know it. All of the momentums in the beginning have to equal all of the momentums in the end. Totally inelastic. So for these, this is the perfectly inelastic, totally inelastic, sticky collision. This is when you have 2 objects and they stick together. So it's the reverse of the explosion, right? So with the explosion, you started off with 1 mass and it spread out into multiple masses. With this one, you start with the multiple masses and then you end up with just 1 mass. So in this, you're going to lose kinetic energy in this. So speed is going to be lost. It has to be dissipated energy through heat and sound, specifically. So for this, I would say objects stick. Objects stick as a result of a collision. Most of the kinetic energy, well, we'll just say a bunch of kinetic energy is lost. So for the relationship between the initial and final, if most of it is lost, then of course your kinetic energy in the beginning is going to be much, much greater than your final kinetic energy. Momentum. Remember, in every type of collision, momentum is conserved. So you can remember that fact and you can memorize it, but can you recognize when a collision has happened? You've got to really read these problems and picture what's happening. Sketch it out to fully understand what's happening in each problem and which strategy should you use to solve the problem.